everyone. I hope you all are good and you all are practicing problems. Let us now focus on this question, and this is going to be one very interesting discussion. Again, this is something that you already know. We just need to look at it very carefully, and then we need to apply whatever we know. This will involve a little bit of concept and then a little bit of mathematics. So let us start with this question. हमारे पास एक insulating rigid rod है, ठीक है, and this is of negligible mass. So this is that rod, okay, and at one end of it there is a small ball of charge minus q and mass m attached over here, okay, and one end of it is fixed at point O. Okay. Now what is said, another small ball carrying a positive charge Q is fixed at a height h above the point O as shown in the figure. So there is one more charge over here. Okay. This is said. What should be the range of values of m of the lower ball so that rod remains in a state of stable equilibrium? Acceleration due to gravity g. Now what is this stable equilibrium? अगर आपको याद हो work energy वाला जो चैप्टर है ना उसमें आपने जरूर किया होगा. सो स्टेबल इक्विलिब्रियम मीनिंग, I mean, first of all, body is in equilibrium, and then if you displace that body by small angle or a small distance, and by displacing that, if you see that there is restoring force which is trying to bring it back to the position of equilibrium, then we will say that equilibrium is a stable one. Otherwise, if you are displacing it by a small distance, and after displacement it has no tendency, it is showing no uh, desire or willingness or tendency to come back to the original position, then we will say this is a case of unstable equilibrium. जैसे बहुत ही famous सा example आप लोग देखते होगे. If you are keeping a ball over here, if you give it a nudge, I mean, if you're giving it a small displacement in this or this direction, it will never come back again to this position, right? But similarly, if you take a ball over here and then you give it a small nudge, again it will go like this and come back to this position. So it will try to come back to the original one. It can also oscillate, I mean, if that push energy is not getting dissipated, in that case it will keep on oscillating like that. But again, by getting displaced by a small distance, it will have tendency to come back to the original position, and this state is called stable equilibrium. So if you have to check for if equilibrium is stable or not, you need to disturb it by a small displacement or angle from the equilibrium position. So यहाँ पे if it is talking about finding out the range of mass m so that this system is in a stable equilibrium, this system of rod hanged with, I mean, this system of rod hanging from the point O which is supporting a charge of minus q at its another end. तो हमारे पास कंडीशन क्या होना चाहिए? I mean, by after small displacement, there should be force acting on it which is trying to restore it. Or you may say there will be torque acting on it which will try to restore it. आपको यहाँ से एक चीज और याद आ रहा होगा, SHM का केस. So whenever we have to check for if body will perform SHM or not, we disturb it from the equilibrium position, right? And in the case of stable equilibrium only, we get to see cases of simple harmonic motion. Otherwise, it won't be it won't be performing such oscillatory motion. जैसे यहाँ पे आप देख रहे हो, it won't be at all oscillatory, right? So basically देखो, ये क्वेश्चन बहुत सिंपल है. ऐसे अगर आपके क्वेश्चन में सिंपल ये होता, there is no charge over here, there is only this mass m, let's say, and we have dealt with this topic, right? This is simple pendulum case, and we know that when we displace it by a small angle, I mean, at this point you write forces acting on it like this is mg, and this is mg sine theta, and this is your mg cos theta. And we know that if this theta is small, this mg sine theta will almost point towards the equilibrium point, right? Equilibrium position. Done it. So for case of a small displacement, we will feel like there is a force acting towards this point, and that is equal to mg sine theta. And if this force is small, sine theta ko theta likhte ho. Theta ko later on, if this is x and this is L, you will treat it like this is center and this is the arc. So theta will be x by L, and force will be directly proportional to displacement. So this thing we have already done, right? ऑल्सो इसको आप एंगुलर एसएचएम से भी सॉल्व कर सकते हो. सो इन दैट केस यू कैन, आई मीन दिस इज द इक्विलिब्रियम पोजिशन, यू गिव इट अ स्लाइट नज, एंड एट दिस nudged point what you do is you do the torque acting on it. So mg force is this tension force का कोई torque नहीं लगेगा, it is passing through this point, and torque of mg around this point will be this one. This is your mgl sin theta. ठीक है, so this is torque, and torque will be I alpha, that is ml square into alpha is equal to this. And from here again you will be getting alpha is directly proportional to theta, sort of, right? Done है. And also angle will be opposites, I mean direction of alpha and displacement thing is oppositely directed, so यहाँ पे एक negative sign भी आएगा. So we have dealt with this thing. अब यहाँ पे question यही है, only difference is now what you are doing is you are keeping here, जैसे इसको मैं थोड़ा छोटा बनाती हूँ. So what is here, here this point is O, and from this point there is a rod hanged, and this has a charge of minus Q, and then there is this charge plus Q. Now you do one thing, I mean, let us first talk about the equilibrium. So in equilibrium, this has a force acting mg. We are talking about equilibrium of this system, right? So we will write its equation mg, and then here will be tension thing, and also here will be what thing? This is gravitational force, sorry, electrostatic force acting. So on minus q charge, force will be attractive. So plus q will try to attract it towards itself. Force direction is this one, and this will be kq divided by h plus l ka whole square, where l is this, h is this, right? So in equilibrium position, you will be saying that T plus this electrostatic force has to be equal to mg. Now let us disturb it from the equilibrium position. अब आप इसको यहाँ से disturb करो. So if you are disturbing it, let's say it was initially here, now it is here. ठीक है. सो एट इक्विलिब्रियम व्हाट आर द फोर्सेस एक्टिंग? प्रीवियस केस में आप जो किए हो ना, सिंपल वही है. वन एडिशनल फोर्स इज गेटिंग एडेड, दैट इज योर इलेक्ट्रोस्टैटिक फोर्स. तो सबसे पहले देखो, टेंशन इज दिस, टेंशन विल फाइंड नो कंपोनेंट इन दिस डायरेक्शन because it will become tangent to it, right? So towards the directed towards the equilibrium point, there won't be component of tension, right? So that is why we are not finding it mentioned over here. Okay, so this is this thing. अब आप यहाँ पे forces लगा लो mg. mg, let's say this angle is theta. So this is again, this angle is theta. So mg sin theta is towards this direction, right? And in this direction, it will be mg cos theta. And again, I mean, this q charge is over here, plus q. अब आप देखो दोनों के बीच में separation line क्या है. So check for that. This is the separation line, okay? Done it? This is the separation line. Along this line, force will act. And this force will have direction of this one. This is Fe. And this Fe will have component in which senses. So it will have component. I mean, इसको और भी अच्छे से draw कर दूं मैं, because it's not looking good. यहाँ से आप इसको ऐसे बनाओ, ठीक है. सो दिस इज योर एफी का लाइन, एंड दिस एफी फोर्स, आई मीन लेट्स से दिस एंगल इज समथिंग. सो लेट अस कॉल इट, दिस वन वी हैव कॉल्ड थीटा, लेट अस कॉल इट अल्फा. ठीक है. सो इफ दिस एंगल इज अल्फा, देन एफी विल हैव वन कंपोनेंट अक्रॉस which direction? I mean this is alpha, and दिस एंगल, एक काम करो, इससे आप ये वाला जो डायरेक्शन है ना, इससे आप ऐसे एक लाइन बनाओ. सो इन दिस डायरेक्शन एफ विल हैव अ कंपोनेंट, एंड दैट विल बी योर एफी साइन अल्फा. ठीक है. एंड अनदर कंपोनेंट विल बी अलोंग विच डायरेक्शन? अलोंग परपेंडिकुलर टू इट, विच इज अलोंग द लेंथ ऑफ स्ट्रिंग, सो इन द डायरेक्शन ऑफ टेंशन. सो अनदर कंपोनेंट विल बी इन दिस डायरेक्शन, दैट इज योर एफी कॉस अल्फा. सो इन दिस डायरेक्शन वी डोंट नीड टू डील विथ, क्योंकि इस डायरेक्शन में वो सिंपल सर्कुलर मोशन में आप लिख सकते हो. सो यू कैन टॉक अबाउट लाइक राइटिंग नेट फोर्स टुवर्ड्स द सेंटर इक्वल टू mv square by r. But that is not the point of discussion over here. We need to check for what is the force acting towards the equilibrium position. Done है? And in order for this equilibrium to be stable, I mean restoring force should act towards this direction. Done it? And force in this direction will only act if mg sin theta is greater than fe sin alpha, right? So mg sin theta has to be greater than fe sin alpha. क्योंकि देखो, अगर ये fe sin alpha बड़ा हो जाता है, तो इस पेंडुलम पे इधर की तरफ नेट फोर्स लग रहा है, and in that case, after small displacement, it has no desire or willingness to come back to the original position. Done it? And in that case, we will say that equilibrium is not stable. So for equilibrium to be stable, force should be directed towards this point, right? Certain component of forces. And here it is mg sine theta minus fe sine alpha. So you will say that mg sine theta minus fe sine alpha था, right? Yes. Okay, theta यहाँ पे अल्फा लिखना चाहिए, sorry. So this is your minus Fe sine alpha. This has to be greater than 0. Okay, that is mg sine theta greater than Fe sine alpha. Now we need to solve for it. अब देखो यहाँ पे हमारा mathematics enter करेगा, and what we can use, बहुत ही simple सा rule है mathematics का, you all must be knowing this one. If this side is A and this angle is alpha, if this side is B and this angle is beta, if this side is C and this angle is gamma, then you know that A by sine alpha is equal to b by sine beta is equal to c by sine gamma. ठीक है, this is simple rule, you know, right? So let us use this one in order for what, in order for the calculation of this thing, simplification of this thing. Okay, so mg sine theta, साइन थीटा को आप क्या लिखोगे? I mean, here we have given a small displacement, right? Because for checking equilibrium thing, we give a small displacement. So since displacement is a small, this theta angle will be how much? It will be very, very small. And you know that if an angle is small, then sine theta can be written as theta. Done है? So if this theta is small, this alpha will also be small. Why? क्योंकि आप देखो ये वाला एंगल कितना हो जाएगा? This is theta, this is 180 minus theta. So this angle is almost closer to 180 because theta is very small, right? So this angle is almost equal to 180. And if you talk about this triangle, then this angle and this angle, let's say this angle is beta. So beta and alpha has to be very, very, very small, right? So sin alpha को भी आप alpha लिख सकते हो, sin beta को भी आप beta लिख सकते हो, ठीक है? So यहाँ पे what I will do is mg sin theta, theta को मैं theta लिखने वाली हूँ, is greater than fe. Fe को क्या लिखोगे? k q q divided by this distance का square. Which distance? This one. So let's say this is r for time being. So r का square and this is your alpha. Okay. Now how we can relate this theta and alpha? So आप triangle की बात करो, हमारा diagram कुछ ऐसा दिख रहा था. This was the equilibrium position. We have disturbed it a bit, and it is, this charge is at this point, and then this is this triangle, right? So this angle is your alpha. This, sorry, this was beta we have taken, right? This angle is your alpha, and this angle is 180 minus theta. Done it? Let's say this is R and this is how much H and this is how much L. So if you apply here H, I mean H by क्या लिखोगे आप? H by you can write sin alpha and this is equal to how much? L by cos beta. ठीक है? Sorry, sin beta. And then you can write R by sin 180 minus theta, that is R by sin theta. ठीक है? So this thing we can do. अब यहाँ से आप अल्फा बीटा सिंस स्मॉल है, H by अल्फा को आप क्या लिख सकते हो? L by beta. So basically, here we have to talk about what theta and alpha, right? So from here we are able to get the relation of alpha and beta, and alpha, beta and theta are related, right? So if you look into this triangle, 180 minus theta plus alpha plus beta is equal to 180, right? So alpha plus beta is equal to how much? Theta. And from here if you note, I mean यहाँ से अगर आप देखो, we need the value of theta by alpha or alpha by theta. So let's say theta by alpha we require. So what I will do is divide this with alpha, this one with alpha, this one with alpha. So this will become 1 plus beta by alpha. अब यहाँ से देखो beta by alpha को आप क्या लिख सकते हो? Beta by alpha can be written as L by H. So यहाँ से मैं लिखूंगी L by H, ठीक है? And this is equal to theta by alpha. So theta by alpha is equal to how much? H plus L by H. Done it? Now let us simplify this further. theta mg theta by alpha should be greater than how much? That is your I mean Fe, that is your k q q by r का square. Okay, so theta by alpha क्या दिख रहा है? mg L plus H divided by h greater than kqq by r ka square. Now let us calculate this r thing. So for that again we will be using one mathematics, and that is very simple. Like if triangle is right angle triangle, then we know that if two sides are given, we can easily calculate third side, right? If this is a, this is b, we can write it like a square plus b square. But what if sides are not I mean if the triangle is not this is right angle triangle, right? So in that case also we have one formula, like agar yahan pe dekh lo, this triangle is something like this. Let's say this angle is theta, and this is a, this is b, and we have to calculate value of this side. Then that you will be writing as a square plus b square minus 2ab cos theta. ठीक है, root under. This will be the value of c. So this is one new law. You must have studied this thing in trigonometry. ठीक है, सो आई विल बी यूजिंग दैट. अब देखो यहाँ पे आर हम कैसे निकाल सकते हैं. यू नो दैट दिस इज द आर. सो दिस ट्राइंगल यू रीड्रॉ हियर, इट इज दिस थिंग एच एंड इट इज दिस थिंग एल. ठीक है, सो एच इज नोन, एल इज नोन, एंड दिस आर इज नॉट नोन, बट वी नो एंगल दिस इज 180 minus theta. So what will be the value of r? It will be equal to h square plus l square minus 2hl, and this is cos 180 minus theta, right? That is the angle between h and l side. Okay, so this will become how much? H square plus l square. Cos 180 minus theta is how much? This angle is in second quadrant. Second quadrant cos is negative, so this will become minus cos theta, right? So this will become overall plus 2hl. Okay, cos theta. Now again we need to use the approximation, right? So theta we have taken as very small. If theta is very small, then cos theta will approximately equal to 1, and in that case you will get it as h plus l ka whole square, root under, right? So this will give you h plus l. डन है. सो अगेन दिस विल बी एच प्लस एल, और डायरेक्टली हम इसको लिख सकते थे, इतना करने की जरूरत नहीं थी. सिंस दिस डिस्प्लेसमेंट इज स्मॉलर, वी कैन से वट एवर इज दिस डिस्टेंस बिकॉज दिस एंगुलर डिस्प्लेसमेंट इज वेरी स्मॉल. डन है. सो यहाँ पे आप फाइनल आंसर क्या लिखोगे? एम जी, दिस इज योर हाउ मच ग्रेटर देन के क्यू क्यू एच divided by r square is how much? H plus l का whole square. One more l plus h is there, so l plus h का whole cube. Done है. So m should be greater than k q q h divided by, k को आप break कर सकते हो 1/4 pi epsilon naught, but I am not done it here. L plus h का whole cube. So this will be your answer. Okay, I hope you have understood it, but also I want you to try this question with torque method. I mean you can apply torque on it. जैसे यहाँ पे equilibrium position है, you disturb it and then try calculating torque because of forces acting. ठीक है, so torque you will be calculating around the fixed point, क्योंकि whenever system is fixed around certain point, it's convenient, I mean always suggested to calculate torque around that point. So if you calculate torque around this point, mg का अगर आप torque निकालोगे, so this is r cross mg, and in that case, in this case, there is one more force acting, that is your electrostatic force. So calculate the torque of this force around this point, and that will be, I mean, how much? Again, you need to check for this is r cross f. This much crossing you will do. So for this angle, you need to check and you need to write the value. Again, देखो यहाँ पे restoring torque कब लगेगा? Which torque will try to restore it? The torque which is I mean yeah, which is clockwise, right? So one which is clockwise will try to bring it back to the original position. Another which is anti-clockwise will try to take it further away. So definitely here torque of mg should be greater than torque of electrostatic force. और यहाँ से तुम्हें आई फील लाइक ज्यादा एंगल का कॉन्सेप्ट यूज नहीं करना पड़ेगा, बिकॉज देखो tau mg if you write here, that will be equal to mgl sin theta, right? And if you write this one, this will be equal to how much? Fe, and this is L, and this will be how much? Sine this angle, right? So this is your because if this angle is alpha, this is your how much? 180 minus alpha. So sine 180 minus alpha is nothing but sine alpha, right? So Fel sine alpha. अब यहाँ से आप directly इसको देखो, L will get cancelled, and from here you will be writing mg mg theta by alpha, again you're getting the same thing, right? Is greater than fe. So it is the same thing almost. Then again you can put the things, you can get the answer. So I hope you have understood this question, but if you have doubts anywhere, you can always let me know in the comment section. Thank you. Take care of yourself. Bye bye.